Welcome to Chapter 11, Fossil Fuels. In this chapter, we're going to look at some hotbed topics. First thing, we're going to look at coal and coal production. Coal production is environmentally, very environmentally unfriendly, I guess I should say. Underground mines are more friendly than the open mines, and when you start to see pictures of these, you'll understand why. So lots of environmental degradation by digging up coal, and then coal is also the dirtiest of all fossil fuels, and that we'll be looking at when it's used, when it's burned for air pollution. Then the next we'll be looking at oil and also natural gas. Natural gas and oil, hotbed topics right now in the United States. Movement of that oil and natural gas that we're getting from the shale reserves that we have and up through Canada down into the Gulf states so that it can be refined. It's the Keystone Pipeline. So that's a very hotbed topic that we'll be discussing as well. So let's get started. Why do we worry about fossil fuel? We use fossil fuels for energy, whether it's going to the grocery store in our car or turning on our air conditioners. We have to have this. Looking at the data chart that we have, the largest consumers of energy, US and China, and one of the ways that energy, especially electricity, is measured is in British thermal units, or BTUs. And just so you can kind of understand, 1 BTU equals 252 calories. Remember, 1 calorie, it moves the temperature of water 1 degree. BTU equals 1,054 joules, and many times you'll see joules, megajoules, which would be 1,000 joules, or million joules, sorry, million, not 1,000. But if we look over on the right here, we have our total energy consumption in purple, and then per capita energy consumption. And what you see, total energy consumption in the United States is enormous. It is the highest of any country. And then per capita, we're not quite as high as Canada. Canada per person uses a lot more energy. These are the different types of energy that we use to provide electricity and to provide transportation. 35% petroleum, natural gas 24%, coal 19%, and nuclear and renewables under 10%. And this is U.S. energy consumption. And this is just breaking that pie chart down. And if you look at the petroleum use that we have, 35%, and then here it's broken down into categories. 71% goes to transportation, 23% for industrial, 5% for residential commercial, and then 1% for electric power. So for electricity, we don't use much petroleum. Looking at coal. Coal is interesting. We're just going to look. 91% of coal is used for power production. So quite a bit, and we'll talk about that a little bit more. Natural gas. The natural gas is split about 33% industrial, residential commercial 32%, and 31% to create power. Your power here in South Florida comes from natural gas. Our power plants or electric plants use natural gas to create the electricity. And when we're talking natural gas in homes and residential, we're talking natural gas that actually flows in, and people use that either for their dryer to heat their hot water, or for their stoves if they have it available in their neighborhoods. So you can get appliances that are natural gas. We need to look at our U.S. energy policy just a little bit. We'll start out here, and basically we've got 4 different parameters that go in this policy. Policy is to be energy efficient and to conserve as much energy as possible. Now, efficiency and conservation are different. Efficiency means to utilize the energy but use less of it to do the same thing. So appliances now are very energy efficient. They take, many of them, about 1/4 of the energy to run for 24 hours that they did when I was a kid. So they're much more efficient. Okay? Think about cars. Cars get more miles to the gallon. My car gets anywhere from 28 to 32 miles to the gallon. The car that I got when I was 16 got 8 miles to the gallon. So we're much more efficient. An example, if you drive 75, you're going to use 50% more fuel than at 55. That used to be true, not so much with these new cars that we have now. In order to become more efficient, then we need to eliminate subsidies or federal funds which decrease the consumer price. In Europe, gas is about double what it is here per gallon, and it's computed in liters, but if you equate it, it's about double, maybe a little bit more even. Second thing, first we're going to increase efficiency, and hopefully by increasing efficiency, then we're conserving too, which means to not use as much. Then 2, securing future fossil fuel energy supplies, import and domestic. We want to make sure that there's going to be enough. So we want good technologies here in order to recover the fossil fuels that are here. That will be, the technologies need to be environmentally friendly, and we also, for imports, we have to have good relationships with other countries. And then number 3, develop alternative energy sources. This is expensive to do, takes a lot of research and development, funding. The federal government in the past 7 years has been very friendly to this, but one thing that has decreased the amount of dollars people want to put into alternative energies is the availability of the natural gas in the Bakken up in North Dakota and the Marcellus up in Pennsylvania, those shales, and we'll talk a little bit more about that. So people don't want to put a lot of money behind alternative sources because the fossil fuel sources have increased in supply, therefore looks like they'll last longer. So, and I'll talk about that in a little bit too. And then the 4th one's very important. We need to do the first 3 without creating more damage to the environment. And that's not always the easiest thing to do. We can minimize damage, but there's probably going to be more damage. How were fossil fuels formed? Well, around 300 million years ago, organisms died, and the death was very fast, and they were covered with earth before they completely decomposed. So you have this organic matter that is not decomposed, that has layers of earth on top of it, creating pressure. So it's pressure from the top and pressure and heat coming from the Earth's core that over this 300 million year time period turned these into usable fossil fuels. Now remember, anything that's an organism has carbon in it, and carbon is the issue with burning these, putting carbon into the atmosphere again. So coal came from plants primarily. Oil comes from microscopic aquatic organisms, and natural gas, microscopic aquatic organisms as well. The difference between oil and natural gas is natural gas is under a higher pressure and a higher heat, so it, if you will, vaporizes it. Oil, when it comes out of the ground, it doesn't look like the gasoline that goes in your car or the oil that goes in your car, nice and smooth and slick and very liquid. It's a thick, sludgy, viscous material, and it has to be heated in order to change its chemistry. And this is where we will start part 2, types of coal mining.